Welcome back to our video series. In the first part of this tutorial series, we demonstrated how to create a Gempy model from scratch. In the second part, we focused on incorporating faults as essential geological features. Today, we will explore another powerful tool in Gempy, Onlap relations. To follow this tutorial, make sure you're familiar with Gempy's core structures, particularly structural groups and scalar fields, as covered in previous videos. So far, we have introduced two types of bottom relations, or stack relations, for structural groups in Gempy. By default, the ERODE relation causes younger groups to cut into older ones, forming unconformities. Setting a group's relation to fault makes it behave as a fault, offsetting older elements accordingly. Now we introduce a third option, Onlap. Sometimes, instead of eroding older layers, we want younger units to gradually build up against existing structures. This is common, for example, in sedimentary basin settings and sedimentary channels, where layers of sediment accumulate over time, conforming to the shape of older formations. While the concept is straightforward, its implementation in Gempy requires some considerations. Since Gempy defines geological elements by their bottom surface, we need to find a way to also define a top surface. This is essential for correctly modeling onlapping layers. Let's take a look at an example. In this model we have input data for 4 structural elements. The green and blue points appear parallel, forming a basin structure, so we group them into a single structural group. The yellow and red points represent horizontal layers, forming a younger structural group. Using the default ERODE setting for all groups, we get this model. As expected, the younger group cuts into the older one, creating an unconformity. To make the younger layers onlap onto the older basin structures instead, we changed the stack relation of the younger group to onlap. Here's the updated model. While this result is what we aimed for, there are some technical considerations. Notice that the element called basin top now serves 2 roles. First, its boundary surface, defined by input data, forms the structure onto which younger layers onlap. Second, its volume fills the space between this surface and the next rock layer. This dual role can make naming conventions tricky. Also, basin top is placed in the same structural group as basin bottom, which makes sense for defining the onlapping surface. However, from a geological perspective, its volume should belong to the younger group with basin fill 2 and basin fill 1. Depending on the available input data, it is sometimes possible to place basin top, the onlapping surface, in its own structural group. In this case, the element is already well defined by its provided data, meaning we don't need information from basin bottom to interpolate the onlap surface. Remember that grouping elements together causes them to be interpolated by a single scalar field. Since the onlap surface is independently constrained, we can place basin top in a separate structural group and the resulting model remains nearly identical. This demonstrates how onlap relations can help create realistic sedimentary settings, but also require careful structural planning in your Gempy model. We hope you found this new onlap tutorial helpful. If so, leave a like on this video or maybe even stop by GitHub and grant Gempy a star rating. Are there any topics you would like us to cover? Make sure to leave a comment. By subscribing, you make sure to miss no informative Gempy videos in the future.